So now we will now find the power series of cosine x. So here's the formula for the Maclaurin's series. So in Maclaurin series, our c is equals to 0. So first you have to find the derivative of the cosine x, which is negative sine x. Second derivative, negative cosine x. Third derivative, sine x. The fourth derivative is cosine x. So now we will just substitute our c in our function. So cosine 0 is equals to 1. Negative sine 0 equals to 0. Negative cosine 0 is equals to negative 1. And sine 0 equals to 0. Cosine 0 is equals to 1. And so we will now substitute our function here in our formula. So the first term, f of c, is equals to 1. And the second, first derivative is equals to 0. So 0. The next one is second derivative, which is negative 1. So this will become negative, and 0, 0. And the x squared will remain, so x squared over 2 factorial. The next one is 0, so 0. The next one is the fourth derivative, which is 1, which is 1, so positive. So if we continue, it will become negative, and x raised to 6 over 6 factorial, and so on. So as we can see, our exponent is odd or even, 2, 4, 6. The same goes as the factorial in the denominator. 2 factorial, 4 factorial, 6 factorial. And you can also observe that our sign is alternating. So we can conclude that cosine x is equals to the summation and equals to 0, infinity. So negative 1 raised to n times x raised to 2n over 2n factorial. So if we substitute 0, so 0, negative 1 raised to 0 is equals to 1. So x raised to 2, 0 plus to 1, it will become 1. So 2, 0, so 0 factorial equals to 1. So 1 over 1 is become 1. So times 1, so it's just the same as 1. So if the n is 1, so negative 1 raised to 1, so it become negative 1. So negative. So nx raised to 2 times 1, so it will become x raised to 2. And 2 raised to 1, or 2 times 1, it will become 2 factorial. And so on and so on. So we can conclude that the power series of cosine x is equals to